The most advanced fighter jet in the world just got a game-changing mission. The United States Air Force has officially confirmed that the legendary F-22 Raptor will become the first operational fighter aircraft to command next-generation autonomous drones in combat. This isn't just an upgrade. This is a complete transformation of how America dominates the skies. Right now, as we speak, military engineers are finalizing plans to retrofit 142 combat-ready F-22 Raptors with cutting-edge tablet-based control systems. By October 2025, contracts will be awarded, and by June 2026, these stealth fighters will be commanding swarms of artificial intelligence-powered collaborative combat aircraft in real combat scenarios. The price tag: $15 million for the first phase alone, with each individual upgrade kit costing over $86,000. But here's what makes this absolutely revolutionary. We're not talking about some distant future concept. The Air Force has already allocated $870 million for fiscal year 2026 to advance this program. 2 prototype drones are already in development: General Atomics YFQ-42A and Anduril's YFQ-44A. The goal: deploy over 1,000 of these loyal wingman drones by 2030. Welcome to Jet Insight, where we bring you the most critical developments in military aviation. What you're about to discover will change everything you thought you knew about air combat. The F-22 Raptor, once designed purely for air superiority, is about to become the command center for the most sophisticated drone warfare system ever created. Each pilot will control multiple autonomous aircraft simultaneously, extending America's reach across contested airspace while keeping our brave men and women out of harm's way. This represents the largest tactical shift in air combat doctrine since the introduction of stealth technology itself. If you're as excited about this breakthrough as we are, type "proud" in the comments below and let us know what you think about America's latest technological advantage. The birth of a new era. The Crewed Platform Integration Program, officially designated with Military Code B, marks an unprecedented leap forward in manned-unmanned teaming capabilities. This isn't just about adding new equipment to existing aircraft. This is about fundamentally reshaping how the United States Air Force projects power across the globe. The decision to select the F-22 Raptor as the first platform wasn't made lightly. Out of America's entire fighter fleet, including the newer F-35 Lightning II, military strategists chose the Raptor for very specific reasons. The F-22's inter-flight data link system provides virtually jam-proof communication capabilities. This secure, encrypted network already connects F-22s to each other with unmatched reliability. Now, that same technology will link human pilots to their artificial intelligence wingmen. Consider the implications. A single F-22 pilot, already operating the world's most advanced fighter aircraft, will soon command multiple autonomous drones capable of electronic warfare, reconnaissance, and strike missions. These collaborative combat aircraft will scout ahead, jam enemy radar systems, and engage targets while the human pilot maintains strategic oversight from a position of superior stealth and speed. The transformation begins with hardware integration. Each of the 142 combat-coded F-22s will receive ruggedized tablets specifically designed for high-speed, high-stress combat environments. These aren't commercial devices. They're military-grade systems capable of withstanding the extreme forces of supersonic flight and aerial combat maneuvers. But the real breakthrough lies in the software. The artificial intelligence controlling these drones has been developed through years of testing with modified F-16 Fighting Falcons under Project VENOM. The Experimental Operations Unit has evolved from a small test program into a full squadron, validating autonomous behaviors including formation flying, electronic warfare, and adaptive combat tactics. The strategic advantages are immediately apparent. Enemy forces will no longer face individual aircraft. They'll confront coordinated swarms of manned and unmanned systems operating as a unified force. The F-22's stealth capabilities mean adversaries won't detect the command aircraft until it's too late, while the autonomous drones can be deployed in high-risk scenarios without endangering human pilots. America's technological supremacy. This development couldn't come at a more critical time. As global tensions rise, and potential adversaries develop their own advanced military capabilities, the United States continues to demonstrate why American innovation leads the world. The integration of F-22 Raptors with collaborative combat aircraft represents more than technological advancement. It's a statement of American resolve and ingenuity. The numbers tell the story of American commitment to maintaining air superiority. The initial procurement includes not just the tablets and control systems, but comprehensive training programs, system integration, certification processes, and ongoing support infrastructure. The Air Force has allocated $173,000 for advisory and assistance services, $240,000 for simulation and training equipment, and nearly $2 million in program management costs. The timeline reflects the urgency of this capability. Contract awards begin in October 2025, with hardware delivery scheduled for June 2026. 56 installations will be completed within the first fiscal year, demonstrating the Air Force's commitment to rapid deployment. This isn't a research project. This is an operational capability being fielded as quickly as possible. The choice of contractors speaks to the quality of American defense innovation. General Atomics, already renowned for their Predator and Reaper drone programs, brings decades of unmanned systems expertise to the YFQ-42A development. Anduril, representing the new generation of defense technology companies, contributes cutting-edge artificial intelligence and autonomous systems knowledge to the YFQ-44A platform. These collaborative combat aircraft aren't simple remote-controlled vehicles. They're sophisticated autonomous systems capable of making tactical decisions in real time. The artificial intelligence has been trained on countless scenarios, learning from the best human pilots and tactical experts. When deployed alongside F-22 Raptors, these drones will execute complex missions with minimal human intervention, allowing pilots to focus on strategic decision-making and overall mission command. The modular design of these systems ensures adaptability across different mission profiles. Electronic warfare variants can jam enemy communications and radar systems. Reconnaissance models provide real-time intelligence gathering capabilities. Strike variants carry precision munitions for engaging high-value targets. All variants operate seamlessly under the command of their human controllers. Transforming pilot training and tactics. The integration of autonomous drones with F-22 Raptors requires a fundamental evolution in pilot training and tactical doctrine. America's finest aviators are already adapting to this new paradigm, developing skills that combine traditional fighter pilot expertise with drone command capabilities. Training programs have been specifically designed to address the unique challenges of controlling multiple autonomous systems while maintaining situational awareness in high-threat environments. Pilots learn to delegate specific tasks to their artificial intelligence wingmen while retaining ultimate command authority. This human-machine teaming approach leverages the best capabilities of both systems, human judgment and creativity combined with artificial intelligence speed and precision. The tactical implications extend far beyond individual aircraft performance. Formation flying takes on entirely new dimensions when human pilots can position their autonomous wingmen for optimal mission effectiveness. Electronic warfare becomes more sophisticated when multiple platforms can coordinate jamming and deception operations simultaneously. Strike missions achieve unprecedented precision when human pilots can designate targets for autonomous engagement while maintaining defensive positioning. Simulation systems have been developed to train pilots in these new capabilities without risking valuable aircraft or human life. These advanced training environments replicate the complexity of modern combat scenarios, allowing pilots to practice commanding multiple drones against sophisticated enemy threats. The simulation systems include realistic representations of enemy air defense systems, electronic warfare capabilities, and counter-drone technologies. The psychological aspects of human-machine teaming receive special attention in training programs. Pilots learn to trust their artificial intelligence wingmen while maintaining appropriate oversight. They develop intuitive understanding of autonomous system capabilities and limitations, enabling effective task delegation in high-stress combat situations. Mission planning evolves to accommodate the expanded capabilities of hybrid manned-unmanned formations. Traditional air-to-air and air-to-ground missions now include considerations for autonomous drone positioning, task assignment, and coordination. Pilots learn to think beyond individual aircraft limitations, leveraging their entire formation for mission success. Global implications and strategic advantages. The deployment of F-22 Raptors commanding collaborative combat aircraft sends a clear message to allies and adversaries worldwide. America's commitment to maintaining technological superiority remains unwavering, and our military continues to evolve with the changing nature of modern warfare. Allied nations are closely watching this development, recognizing the potential for enhanced coalition operations. The interoperability features being developed will allow American F-22s to potentially coordinate with Allied autonomous systems, creating unprecedented opportunities for multinational military cooperation. NATO partners and Pacific allies see this as evidence of America's continued leadership in defense innovation. The strategic implications for deterrence cannot be overstated. Potential adversaries must now consider facing not just individual American aircraft, but coordinated swarms of manned and unmanned systems. The psychological impact of knowing that each F-22 Raptor represents multiple combat platforms significantly complicates enemy planning and decision-making. Intelligence gathering capabilities receive enormous enhancement through this program. Autonomous drones can penetrate deeper into contested airspace, collecting vital information, while the command aircraft remains in relatively safe positions. This distributed intelligence architecture provides commanders with unprecedented situational awareness across vast operational areas. The economic advantages of autonomous wingmen become apparent when considering the cost of training and maintaining human pilots versus artificial intelligence systems. While human pilots remain essential for command and strategic decision-making, autonomous drones can handle routine and high-risk tasks without putting trained personnel at risk. This approach maximizes the effectiveness of America's most valuable military asset, our highly trained pilots. Logistics and maintenance operations benefit from the modular design of collaborative combat aircraft. Unlike manned fighters that require extensive life support systems, ejection seats, and crew accommodations, these drones can be optimized purely for mission effectiveness. This design philosophy results in aircraft that are not only more capable in specific roles, but also easier and less expensive to maintain. Technological breakthrough and innovation. The artificial intelligence powering these collaborative combat aircraft represents years of development by America's leading technology companies and research institutions. Machine learning algorithms have been trained on vast databases of combat scenarios, pilot decision-making patterns, and tactical outcomes. The result is autonomous systems capable of making split-second decisions that rival human pilot capabilities in many situations. Communication security receives paramount attention in this system design. The Interflight Data Link technology, already proven in F-22 operations, provides the foundation for secure, jam-resistant communication between manned and unmanned aircraft. Enemy forces attempting to disrupt these communications face the same challenges they encounter when trying to interfere with F-22 to F-22 coordination. An extraordinarily difficult task, given the advanced encryption and frequency hopping capabilities. Sensor fusion technology enables these autonomous drones to share information seamlessly with their human commanders. Real-time data from multiple platforms creates a comprehensive picture of the battlefield that far exceeds what any individual aircraft could achieve. This information advantage translates directly into tactical superiority and mission success. The artificial intelligence systems incorporate adaptive learning capabilities, meaning they continuously improve their performance based on mission experience. Each engagement provides data that enhances future operations, creating autonomous wingmen that become more effective over time. This evolutionary capability ensures that American forces maintain their technological edge as operational experience grows. Reliability and redundancy features built into these systems address the critical importance of mission success. Multiple backup systems ensure that autonomous drones can continue operating even if primary systems suffer damage or interference. Fail-safe protocols guarantee that damaged or compromised drones cannot be turned against American forces or allies. For our military veterans and defense enthusiasts watching today, we invite you to join our community of experienced professionals who understand the importance of maintaining America's military technological edge. Your insights and experience help us provide the most accurate and comprehensive coverage of these critical developments. The future of air combat. Looking ahead, the successful integration of F-22 Raptors with collaborative combat aircraft opens possibilities that seemed like science fiction just a few years ago. The goal of deploying over 1,000 autonomous drones by 2030 represents just the beginning of this transformation in military aviation. Future developments will likely include enhanced artificial intelligence capabilities, improved autonomous decision-making systems, and expanded mission profiles for unmanned wingmen. The modular design philosophy ensures that these systems can evolve rapidly as new technologies become available, maintaining America's technological advantage for decades to come. The integration timeline reflects the urgency with which American military leaders view this capability. The transition from concept to operational deployment in less than 2 years demonstrates exceptional project management and engineering excellence. This rapid deployment schedule ensures that American forces will have these enhanced capabilities available when they need them most. International cooperation opportunities continue to expand as allied nations recognize the advantages of interoperable autonomous systems. Joint exercises and training programs will help develop standard procedures for multinational operations involving manned and unmanned aircraft formations. These partnerships strengthen global security while reinforcing America's leadership role in military innovation. The economic impact of this program extends beyond immediate military applications. The technologies developed for collaborative combat aircraft have potential civilian applications in autonomous vehicle systems, artificial intelligence development, and advanced manufacturing techniques. American innovation in military technology has historically driven advancement in civilian sectors, and this program continues that tradition. Research and development efforts continue advancing the state-of-the-art in autonomous systems technology. Universities, private companies, and government laboratories work together to solve the complex challenges of human-machine teaming in high-stress environments. This collaborative approach ensures that American forces benefit from the best ideas and innovations from across the nation. Operational deployment and mission readiness. The practical implementation of F-22 Raptor drone command capabilities requires careful coordination across multiple military organizations and contractor teams. Installation schedules have been developed to minimize impact on operational readiness while ensuring rapid capability deployment. Contract field teams will handle the technical integration work, allowing Air Force personnel to focus on training and operational preparation. Quality assurance protocols ensure that each installation meets the highest standards for reliability and performance. Extensive testing procedures validate system functionality before aircraft return to operational status. This methodical approach guarantees that enhanced capabilities don't compromise the proven reliability that makes the F-22 Raptor such an effective weapons system. Maintenance procedures have been developed specifically for the new drone command systems. Technical personnel receive specialized training to support these advanced capabilities, ensuring that operational readiness remains high throughout the fleet. The integration of new systems with existing F-22 maintenance programs demonstrates the thoughtful planning that characterizes this entire program. Operational testing phases will validate system performance under realistic combat conditions. These evaluations ensure that the theoretical advantages of manned-unmanned teaming translate into practical battlefield effectiveness. Lessons learned during testing phases will inform future system improvements and operational procedures. Technological superiority and national security. The successful development and deployment of F-22 Raptor drone command capabilities reinforces America's position as the world leader in military aviation technology. This achievement represents the culmination of decades of investment in research, development, and industrial capability. No other nation possesses the combination of advanced fighter aircraft, autonomous systems technology, and operational experience necessary to field comparable capabilities. The strategic implications of this technological advantage extend far beyond immediate military applications. Potential adversaries must recalculate their strategic planning when facing the prospect of coordinated, manned-unmanned formations. The complexity of defending against such systems significantly complicates enemy tactical and strategic decision-making. Allied confidence in American military capabilities receives reinforcement through demonstrations of continued technological advancement. Partner nations recognize that cooperation with the United States provides access to the most advanced military technologies available. This technological leadership strengthens alliance relationships and enhances global security cooperation. The industrial base supporting this program demonstrates the depth and capability of American defense manufacturing. The ability to design, develop, and deploy such sophisticated systems in compressed timeframes showcases the responsiveness and innovation of American industry. This industrial capability serves as both a strategic asset and a deterrent to potential adversaries. Investment in autonomous systems technology pays dividends across multiple military domains. The artificial intelligence and autonomous control systems developed for this program have applications in naval operations, ground combat systems, and space-based platforms. This cross-domain applicability maximizes the return on research and development investments. Conclusion: the confirmation that F-22 Raptors will become the first operational fighters to command next-generation autonomous drones marks a watershed moment in military aviation history. This achievement reflects the dedication, innovation, and excellence that characterizes America's military and defense industry. The $15 million initial investment and the planned deployment of all 142 upgraded aircraft demonstrate serious commitment to maintaining air superiority in an evolving threat environment. The timeline from contract award in October 2025 to hardware delivery in June 2026 shows the urgency with which American military leaders view this capability. The integration of human pilots with artificial intelligence wingmen represents more than technological advancement. It symbolizes America's commitment to protecting our nation and our allies through superior capabilities and strategic thinking. Our brave men and women in uniform will soon have tools that enhance their effectiveness while reducing their exposure to danger. The broader implications of this program extend beyond immediate military applications. The technologies developed here will influence civilian autonomous systems, artificial intelligence development, and international security cooperation for years to come. America's investment in military innovation continues to drive advancement across multiple sectors. As we watch this remarkable program unfold over the coming months and years, we can take pride in the dedication and skill of the engineers, pilots, and support personnel making it possible. Their work ensures that America remains the global leader in military aviation and technological innovation. The future of air combat is being written today in American skies, and the F-22 Raptor continues to lead the way into that future. If you found this information as fascinating as we did, make sure to like this video and subscribe for more updates on America's military technological achievements. Your support helps us continue bringing you the most important developments in defense technology and military aviation. The sky truly is no longer the limit when America's finest pilots command both manned fighters and autonomous wingmen in defense of freedom and democracy around the world.